All right, so we're going to talk a little bit about Module 2, Lesson 5 now, and this is a continuation of our last lesson on exponent rules. We're going to have some more today. Sometimes when you're working with exponents, you'll wind up with getting some negative values for some of your exponents, and we need to be able to deal with that. And it's not hard to deal with it once you've learned the rule for it. Basically, if you have a problem with a negative exponent, like this first one here, this x to the minus fifth, we're just going to rewrite it as a problem where all of our exponents are positive. And our rule says just take that piece that has the negative exponent and move it to the other side of the fraction bar and then make the exponent positive. So this x to the minus fifth here is the same as 1 over x to the positive 5 power. Okay, and then similarly down here where we have this x to the minus 3 down in the bottom, we can just take that, we can move it up to the top, and we can make the exponent positive. So our rule here is that if we have a negative exponent, we're just going to move it to the other side of the fraction bar, and we're going to make our exponent positive. Similarly, if we have a negative exponent down at the bottom, we're just going to move it up to the top. We're going to make that positive exponent there as well, okay? This can come up with some problems like this, x to the third over x to the seventh. We know from our last lesson that when we have a division like this, we can subtract these exponents to simplify. And so this would be like x to the 3 minus 7, which would be negative 4, but we never want to leave an answer like this. When we wind up with a negative exponent in our problem, we want to simplify that using those rules from the last slide. We just want to take this, we want to move it down to the bottom, and we want to make that exponent positive. There actually is kind of a simpler way to deal with this problem that I wanted to mention, though. When we have this x to the third over x to the seventh here, okay, what we did up above is not incorrect. It will work just fine. It's just a little bit of extra work to add that negative exponent in there. There is kind of a simpler way that we can deal with these kinds of problems. The way I like to think about it is I'm just going to subtract the exponents here, and I'm just going to subtract big minus small. And so 7 minus 3 is going to leave me with 4 of these x terms left, right? And then the shortcut here is we can just leave that number of x's that we have left over there on the side of the fraction bar where we started with more x's. So since we started with 7 x's on the bottom, we're going to have 4 x's left over, and those 4 x's are going to be down on the bottom, and that'll skip the entire process of going through that negative exponent thing. And so that's a good way to think about this. You know, if you have something like x to the fifth over x to the second, that rule works here as well. You know, we're just going to subtract 5 minus 2. I'm going to have 3 x's left over, and I'm going to wind up with those x's left on the top because I started with more x's on the top. So just subtract your exponents, big minus small, and then leave your result on whichever side of the fraction bar you started with more, and that will work. Okay, so a couple of ways to approach it. They'll both work. I would recommend the second one, just a little more straightforward. Okay, so the next big topic in Lesson 5 is a topic about this thing called scientific notation. Very often in science, we're going to wind up with numbers that are very, very large or very, very small, kind of depending on what branch of science we're working with. So we don't want to write, all of these, 7 characters to write out this number 5,127,000 over and over again. Okay, we want to use a method that's going to make this number easier to deal with. Okay, and so that's what, and this number is not even particularly big. If you're dealing with something like the number of cells in some sort of an object in chemistry, I mean, this number can be much, much, much bigger. So this is strategy we're going to deal with using this thing called scientific notation. Okay, so scientific notation is going to make us rewrite this number as a number where the actual value is between 0 and 10. Okay, and then we're going to use an exponent to represent how many place values we have in this number. So first thing you got to do is locate your decimal. So for this number, the decimal is going to be here at the end. Okay, and then we're going to slide that decimal over so that we have exactly one digit in front of the decimal. So I'm just going to slide it over 1, 2, 3, 4, 5, 6 times in this case. So it's going to be right between the 5 and the 1. So I'm going to rewrite the number with the decimal point right between that 5 and that 1. And of course, I can drop off any of those trailing zeros there. So I'll rewrite this as 5.127, but I do need to take into account the fact that I did move that decimal 6 times to the left. Now, 5,127,000 is a large number. I always kind of think about that first. Is my number that I'm starting with large or small? Okay, so because this is a large number that I'm starting with, I'm going to have a positive exponent on this 10 to the 6th here every single time. So if I start with a large number, my exponent is going to be positive in my scientific notation number. Okay. Similarly, I can look at this one down here, this 0.01375. Okay, I can find my decimal. I know I want exactly one digit in front of my decimal. So I'm going to take this decimal, I'm going to slide it 2 spots to the left, rewrite my number, can drop off all of those leading zeros in this case. Okay, now this number we started with was very small, right? If I start with a small number, okay, then my exponent is going to be negative, and I moved the decimal 2 spots to the right. So I'm going to use a -2 there. Okay, so for large numbers, I'm going to wind up with a positive exponent in my scientific notation number. Okay, for a small number, decimal that's less than 1, I'm going to wind up with a negative exponent there instead. Okay. We'll definitely want to be prepared to kind of go both directions on the test. Like this is a problem where I'm giving you the scientific notation number. We're asking you to put this into standard form. Okay, we're going to kind of follow that same process. I'm going to just in reverse. We're going to take our number, we're going to take our decimal point, and in this case, we're going to slide it 7 times to the right. This is a number that, because of the positive exponent, is going to wind up being large. So I want to take this decimal 1, 2, 3, 4, 5, 6, 7 spots to the right, and then I'm going to fill in all those times I moved over with zeros to take that into account. Okay, so our answer here is going to be, kind of put some commas in there maybe to make it a little easier to manage. So 15,400,000 is going to be our number in standard notation. And again, very large number. This is not unusual to deal with numbers this large in your science classes. So I want to be ready for that. For this next one, same idea. We're going to take our number. We're going to move that decimal, which is, here, 5 spots to the left. This one is going to wind up being very small because my negative exponent on the original problem. So 1, 2, 3, 4, 5 to the left. And then I'm going to fill in all of those times I move that over with zeros. So 0.0000303. So 4 zeros in the front there. Okay, so once again, find your decimal point, slide your decimal point over based on the exponent on your 10. If you've got a positive exponent, you're going to wind up with a big answer. You're going to slide that decimal to the right. If you have a negative exponent, you're going to wind up with a small number. You're going to slide that decimal to the left. If you don't have a decimal written there, it's certainly possible. Like if you have something like 3 times 10 to the 5th, well, we know that the decimal is after the last digit in our number, so we can follow that same process there. We just slide our decimal 1, 2, 3, 4, 5 times to the right, fill in zeros there, so 300,000 is going to be our number there. So if there's no written decimal, we still know based on our previous work where the decimal is. We might ask you to do some simple calculations with scientific notation numbers. Certainly something that you'll spend a lot of time on if you take a chemistry class or a physics class or something like that with these numbers, is doing calculations with them. But for us, we're just going to do fairly basic ones. If we have a problem like this is a division. Okay, and what I'm going to do is I'm just going to kind of divide the pieces that work well together. So 14 divided by 7, I can just kind of do that. 14 divided by 7 is going to give me 2. And then 10 to the second over 10 to the negative 6, we know how to divide these terms that have these exponential terms. We divide, we're going to subtract the exponent. So this would be like 10 to the 2 minus negative 6, right? And then we add those up. So that's 2 times 10 to the 8th. Okay, and then to simplify this, you do want to read your instructions here because it might ask you to use scientific notation on some of these. And if we're asked for scientific notation, we're just done. This is the answer in scientific notation. Other times, though, it'll ask you to give the answer in standard notation. It's important to read your instructions here. So this is the scientific notation answer. If we want the standard notation answer, we're just going to take our decimal and we're going to slide it 1, 2, 3, 4, 5, 6, 7, 8 times to the right. Wind up with a lot of zeros in problems like this. Not unusual to wind up with very large values. It's why we use scientific notation. We don't want to write with all these zeros out to deal with them. Okay? But do make sure on questions like this that you're really paying attention to your instructions, giving scientific notation if you're supposed to give scientific notation, giving standard notation if you're supposed to give standard notation. So hopefully that'll be enough to get you off to a decent start here for lesson 5. Please let me know if you're having any trouble as you're going through it. You can always contact me through the Ask My Instructor button in my math lab or through my email. So I hope you have a good day.